So, what do graphs have to do with economics? Well, they provide a very useful way to build a simplified visual of how the world works. Okay, since economics is all about the choices that people make, let's look at an example that all of you have in common: how a student taking an economics class chooses to use his or her time. Let's make a couple of assumptions about our student. After carefully evaluating for time spent at work, sleeping, eating, social activities, family, there's 10 hours of study time each week. Also, data shows that most students who take economics are full-time, so let's assume that this student is taking a second course. I know, in the real world, full-time means 4 or more courses, but I'm going to limit the number of classes to 2. For one, it's hard to draw a diagram in 3 dimensions, and I'd like to see you try 4 or 5. For another, you'll see that even assuming only 2 classes, we can use this simplified model to illustrate how people make their choices. Now, what's the measurable objective of the student who's taking 2 classes, let's say economics and math, and has 10 hours per week to study? Grades. How well the student is doing is measured by grades. So let's put all of this information in graphical form. First, I set up my 2 axes and label each. One will be the grade in economics, the other will be the grade in math. What's the possible range of grades? Well, anywhere from an F to an A, or since we're counting on this graph, anywhere from 0.0 to 4.0. This is true for the grade in economics axis as well as the grade in math axis. Now, our student goes to classes on the first day. Math class isn't very stimulating, but the econ class is great. You go home, check Blackboard, rewrite your notes, do the practice sets, form a study group, and before you know it, your 10 hours are gone. If indeed you put in 10 hours per week in economics, it's quite likely you'll get an A. But this leaves you with 0 hours to work on math. If you do no studying or homework for math, you're going to get an F. This is our first point on the graph. What if you begin to spend a little time each week on math? Maybe you start spending about 2.5 hours on math and cut back to 7.5 hours in economics. Well, the math grade is going to go up, and that's good news. Now you're at least getting a D in math. But because you took time away from economics, the economics grade is going to fall from an A to a B. And so on. I can follow this pattern. If I were to spread my time such that I was using 5 hours for each class, I would get a C in each class. If I decide to spend 7.5 hours on my math class, leaving me with only 2.5 hours for econ, the good news is my math grade's up to a B, my economics grade down to a D. Finally, I could spend all 10 hours on the math class, giving me an A in the math class, which is great, but that leaves me nothing to study for economics, and now I'm failing my economics class. Are there any other combinations the student could choose? Sure. He or she could pick, 7 hours and 3 hours, or 6.2 hours and 3.8 hours, or 1 hour and 9 hours. There are an infinite number of combinations. These would be shown in the diagram between the points we've already chosen. Did you notice that once we've included all the points, this looks more like a solid downward sloping line than just some collection of points? This is a production possibilities curve, or a PPC, also referred to as a production possibilities frontier, or a PPF. By definition, the PPC, or PPF, shows all possible combinations of output that can be produced, assuming 2 things. 1, a fixed amount of productive resources of a given quality, and 2, efficient use of those resources. Well, did we do all this stuff? Yeah, we looked at all possible combinations of output by examining all possible combinations of grades that were being produced. Fixed amount of productive resources is 10 hours of the student's labor, and efficient use of the resources, well, by definition, efficiency means that there's no unused or wasted or unemployed resources, and with every combination we made sure that the student was using all 10 hours, so there's no unused study time. The production possibilities curve illustrates the positive analysis, all possible ways in which the student can choose to use his or her time. Now for the normative question, what combination will the student choose? What point will the student choose? Well, it depends on the decision maker. A student might choose a C in both classes because at least they'd be passing both classes. But what if the GPA in your major matters more than your overall GPA? If you're a business student, you might choose a B or an A in economics then over a passing grade in math. Well, I can tell you aren't satisfied with these choices. You're thinking, can't I get an A in both? No. Under the current assumptions, 10 hours of study, this combination is currently unattainable. Could I ever get there? Well, sure, if you can get some more time from somewhere, those additional 10 hours somehow. Maybe if you cut back at work or dropped another class or stopped sleeping, I don't know. Could the student choose, say, a D in both classes? Certainly, but you're wasting your resources, so you're not using all of your study hours for the intended purpose, which is getting the grades in the classes. So you see, even our very simple graphical model tells us a lot about how a person with more needs than resources must make decisions. Next time, opportunity cost.